we talked about modes of communication, specifically pull, push, and hybrid modes of communication. And we agreed today that we will be looking on something new known as MANETs. So MANETs are mobile ad hoc networks. So I'll share my slide. So mobile ad hoc networks or MANETs, as it is, when we say mobile, it means those are devices which are not stationary in one place, and they are designed that they can communicate on the move. So you can be having a station which you can communicate on the move. That is why it is put in as mobile. So it is a network which can be maintained while on the move. So MANET consists of a number of mobile devices coming together to form a network as required without any support. Yes, is there any question? I think I'm getting some interference. Please mute. Mute as soon as you join, please. So I was talking about MANET, and I said it's a number of mobile devices coming together to form a network as required without support of an existing inter-network infrastructure. So there is no fixed connection when you are bringing in the aspect about mobile. Mobile brings in the aspect of mobility so that you can have communication between devices on move. So MANET can be defined as an autonomous system of nodes. So the end devices are actually treated as nodes or the different mobile stations, so that each and every node functions as if, or it serves as a router of its own, connected by wireless links. So these wireless links, or the union, forms a communication network modeled in form of an arbitrary communication graph. When I say a communication graph, you will be able to see a graph as depicted in this diagram, so that you can see the mobile stations, mobile station 1, 2, 3, 4, those ones are the mobile devices. So they are able to communicate. And in a sense, we are saying it creates something like a graph. Remember, this is a kind of network which doesn't require a dedicated connection. So as compared to well-known single-hop cellular network model, supporting the need for wireless communication between two mobile nodes, it relies on a wired backbone and a fixed base station. That is the conventional connection that we normally know. But in a MANET, no infrastructure exists. And the network topology is actually changing dynamically in an unpredictable manner, since the nodes are moving about, or the connection points of the devices are on the move. Like, for example, a vehicle which is actually being controlled over the network. That's a very good example. So that these vehicles, to avoid collision, they communicate with each other. So MANETs is a very growing area, again, in transport industry nowadays. So I was saying that in a MANET, no infrastructure exists. A network topology is changing dynamically in unpredictable manner, since the nodes are free to move, and each node has a limiting transmitting power, restricting access to the node only in a neighboring range, so that you realize that you will only be communicating with your nearest neighbors at most of the time, because it's like a router. So you will be communicating to a next neighbor, the next neighbor connects to another neighbor, forming a network. So MANETs are basically peer-to-peer multi-hop wireless networks. That's why I'm saying you are communicating with the nearest neighbor. So MANETs are basically peer-to-peer multi-hop wireless network, which information packets are transmitted in a store and forward manner from a source to an arbitrary destination via intermediate nodes. The intermediate nodes are created as a result of neighbor relationship that you have between the independent end nodes, so that you have a diagram depicted as shown. So as the nodes move or the different stations move about, the connectivity may change based on the relative locations of other nodes. So the resulting change in network topology is known as the local level and must be passed on to the other nodes so that the old topology information can be updated. So you will realize that in any other instance, all these communicating nodes should be able to adjust accordingly their routing table so that it can be updating the change in topology frequently, considering the dynamic nature of manets. So here you can see in this scenario, mobile station 2 in this figure changes its point of attachment from, can you see this MS2? It is changing point of attachment from MS3 to MS4. Other nodes that are part of this network should use this new route now to forward packets to MS2. So I was saying that as soon as there is change or there is movement, then there's a need to reflect the routing table so that the other nodes can use to forward traffic to the different end nodes that they need to communicate. So in this diagrammatic representation, another big issue which comes up is that of symmetric and asymmetric, or in that regard, bidirectional and unidirectional links. Considering symmetric links with associative radio range, for example, if MS1, if you can see MS1 here in this diagram, if MS1 is within radio range of MS3, this is MS3, MS1 is within radio range of MS3, then MS3 is also within radio range of MS1. So meaning that you can discover each other. So the communication links are symmetric, you see? Or you can say unidirectional. This assumption is not always valid because of difference in transmission power and levels of course, transmission power levels and terrain. Sometimes you might be hindered by buildings, making these, and I want you to take manets in form of vehicles. And these are intelligent vehicles which communicate. So when there is barriers, you can realize that in as much as you are within the radio spectrum of another end station, you might not be able to receive the signal owing to sometimes interference or terrain. So routing in a asymmetric network is a relatively hard task. And you know what is routing? Transfer of data packets to destination or among each other within these devices. So it is, in certain cases, it is possible to find routes that exclude asymmetric links. When I say asymmetric links, I mean unidirectional links. So since it is cumbersome to find the return path, the issue of efficiency is one of the challenges encountered in MANET. Because sometimes you might have received packets from another end station, and you realize that that end station has moved to another place. Then it becomes challenging to relay back, you see? So those are some of the issues which are still yet to be addressed in MANETs. The other issue is varying the mobility patterns of different nodes. So that some other nodes are highly mobile while others are primarily stationary. Because a vehicle can be stationary in a certain location, and you realize other vehicles are moving, but they are communicating with each other. So it is difficult to predict a node's movement and direction of movement. And we need to agree that once you are, it is not able to detect the possible direction of movement, then to be able to map the communications and ensure performance becomes a challenge. So that's another key issue still facing MANET. We still have you should still go deeper and understand these challenges in manets. So characteristics of a manet. What, as you have understood what is manet, I said these are end stations which move about. And a very good issue is when, for example, sometimes we arise with a challenge whereby we need people to communicate within a particular range where we cannot have a fixed physical infrastructure. Like, for example, there is a graduation ceremony. Then definitely a mobile service provider will set up its own station to allow the users to be able to be connected. Because at times, you only need that base station temporarily. So I would believe in a sense whereby we have an aspect of a situation where we don't need physical infrastructure. That is when we want manets. Because at the end of the day, the aspect about having an internet is to be able to allow us to connect with each other. So manets here is for us to be able to connect devices or make devices to communicate with each other. So some characteristics of ad hoc networks, or what we say manets, they have dynamic topologies, which we can agree. Topologies keep on changing. And I don't want to talk about the topology at this level. You understand what is topology. So nodes are free to move arbitrarily. So the different stations are moving about. So the network topology is changing randomly and unpredictably when we talk about in manets. So another one is there is also bandwidth constraint and variable capacity links. So wireless links continue to have significantly low capacity than the infrastructure networks, which is one of the characteristics of MANET. You don't expect these wireless stations, which are moving about, to be able to have high bandwidth as such compared to a fixed infrastructure. So that's another characteristic of MANET. There is also energy constraint operation. So some of these mobile stations in a MANET may rely on batteries or other exhaustible means of energies. It is not like you are supplying energy from an electric source or electricity. So these nodes or devices, the most important system design optimization criteria may be energy conservation. So you need to look into a way of being able to supply consistently energy, maybe through solar powering, if at all it can be able to sustain for a period of time. So another challenge is energy constrained operation. The last one characteristic is limited physical security. So manets are generally more prone to physical security threats than wireline networks, which we can agree, because it is something mobile. So if there is a catastrophe happening to one station, then it can appear to have broken that station or a mobile station out of the others. So it might not communicate with the other end devices. So, and again, with this, there is increased possibility of people tapping or doing tapping over data when it is in exchange, which raises another security issue. So again, there is issue of DOS attacks. So can you consider vehicles which are being controlled over the internet and they are moving about over the internet, and there is consistent, people are sending in more traffic, or more traffic is being, there's a lot of traffic within the exchange scenario. So a lot of traffic can create DOS, or denial of service. So meaning other end stations might not be able to receive signals. So to reduce these threats, many existing link security techniques are often applied within wireless networks. So where do we apply these manets, applications of manets? So manets are applied in defense applications. And we want to agree, for example, when people are in combat, you realize that in modern day war, people communicate, and there is a fixed there's no fixed communication line. So you realize that because of technology, radio technology, you realize that people can be able to communicate with soldiers who are in combat when they're moving about in the different combat zones. So many defense applications require on-the-fly communication setup so that you can communicate wherever you are. Because you know, sometimes when you are in war, you don't know where the other colleagues are. So ad hoc sensor networks are excellent candidate for use in battlefield management. So it is very important in defense application. So people who are in control are able to monitor the soldiers who are in combat. There is also crisis management application. So for example, when there are disasters and the entire infrastructure is in disarray, so restoring communication quickly is essential. And the only way is using manets or mobile stations. This is also used in telemedicine, where paramedic assist the victim of traffic accident in a remote location to be able maybe to access medical records for purposes of X-ray. You know, the way before you treat a patient, you also need to know the underlying conditions. So if I'm having a scenario, someone has been involved in an accident and is in a remote location. So I think the only way is if you have a network, which in this case, manets become very important to be able to allow connection with the remote stations. So paramedic may need to instantly relay back to the hospital about X-ray, maybe has taken a picture of the fracture, and then he should be able to get the results or diagnostic results from the hospital. So meaning that it is much applicable in telemedicine, where we want to treat people when we are in remote, or people who are in remote locations. There is also tele geoprocessing applications, which is a combination of GPS and GIS. So an high capacity wireless mobile system enables a new type of application referred to as tele geoprocessing, so that it can be processed automatically considering the GPS location or GPRS location and the GIS locality. So there is also virtual navigation, where a remote database contains the graphical representation of buildings. So you can see that I can take a picture of a remote location and be able to relay. So that relaying of the geographic surrounding or the ground, how it is, can be able to allow us to maybe do emergency rescue plan in a particular setup or point of interest in that regard. There is also education via internet, where opportunities available in internet or remote areas because of economic invisibility of providing expensive last mile wireline internet access can be able to help people who might not, for example, if I want to be able to teach someone who is in Northeastern, sometimes there is no dedicated internet network. Then we can set up a mobile ad hoc network. There is also vehicular area network. Sometimes we vehicular to vehicular communication, or what we normally say V2V communication, which is a growing and very useful application of ad hoc network by providing emergency services and other information. So this vehicular area network is effective in both urban and rural setup, where there is exchange of necessary data, which can be beneficial to any given situation. But in exactly V2V, it means vehicles which actually communicate with each other, vehicular to vehicular communication. So it's a growing area in mobile or manets, mobile ad hoc networks. So that's a brief about manets. Maybe to still extend on that. There's a manual here. So we have agreed that MANET is a part of what we would say wireless. MANETs actually are wireless networks. And it enables us to access computing and communication services on the move. So as soon as you want to bring it clearly, you mean communication services on the move. So there is no traditional infrastructure-based networks when we're talking about these MANETs. So there is no wireless LANs, and what's available is an ad hoc network. So ad hoc networks are useful when infrastructure is not available. In practical, sometimes we have seen situations which, for example, you are in combat. You don't need to set up an all base station there. It is not possible, and it's expensive. So military application, rescue, and home networking becomes very, very important areas where MANETs are applied. So normally it is consisting of a cellular wireless, where single op wireless connectivity to the wired wall is provided. The space is divided into cells. In any communication station, the cells where people connect to each other are known as cells. When I communicate from a mobile device to another mobile device, we are connected via cells. That changing of cell to cell is what we would refer as handoff. Handoff occurs when a mobile host starts communicating via a new base station. So when you change from one base station to another, it is known as handoff. So again, with MANETs, it may need to traverse multiple links to reach destination. Sometimes I communicate from station A before station A to station C, and there is no direct link. Then it means that you might be forced to go through other links. So that mobility is an aspect brought about by changes in mobility, because movement, so that people are moving from one place to another, which again means route changes. So, and we have agreed that in mobile ad hoc networks, host movement is frequent. Stations move, topology change frequently. No cellular infrastructure or multi-op wireless links. So data must be routed via intermediate nodes. There is no dedicated nodes. It is only neighborliness that are now connections. So connections is based on neighborliness. So why ad hoc network? The reason why we emphasize on ad hoc networks is when there is an issue on setting up a fixed access point or a backbone infrastructure. Sometimes it is not possible, or infrastructure may not be present in a disaster area or a war zone. So we normally use ad hoc networks. Or a situation where you might not be able to use Bluetooth. Remember, the range of Bluetooth is 10 m. So the range within which you might not be able to communicate, for example, in a combat situation. Ad hoc networks, its key advantage is that it doesn't need a backbone support and easy to deploy and useful when its infrastructure is absent, destroyed, or sometimes impractical. We have seen applications of these MANETs, military, civilian environments, emergency operation. Challenges of mobile environments or MANETs is limitations of wireless network. Sometimes during communication, there is packet loss. Remember, we said MANETs are very dynamic. In a MANET network, the network is very dynamic. So most of the time there is packet loss. Because someone has sent you some information, the same info, and changed the position. So meaning the routing table has already changed. So that might result into packet loss due to transmission errors. Variable capacity links, and we say that bandwidth is another challenge, because you realize that it requires quite, there is a need for trade-offs, especially considering power requirements or energy requirements of these stations, so that again, there is limited capacity of bandwidth that can be supported in an MANET. Limited communication and the others. So there is limitation imposed by mobility or movement. So there is also limitations of mobile computer. These mobile computing resources that are moving about have short lifetime and limited capacities. So you also need to picture these manets in an aspect of protocol stack, the network protocol stack. How does it impact on the OSI reference model? So you need to look from the point of applications. How do applications need to adapt the application layer, transport layer? How will it be able to manage congestion and flow control? Addressing network, how will it be able to address challenges of addressing and routing? Because the IP address, of course, for a MANET might be static, but that routing aspect, how will be able to manage the packets, the relayment of packets from one station to another? There is also link, that is media access and handoff. That changing from one station to another is also a challenge in the MANETs. So physical transmission errors and interference. So you need to see the aspect about mobile ad hoc networks and how it is able to interfere with the OSI reference or protocol stack. So another issue is about media access control in MANETs. So can we apply media access methods from fixed networks? Remember, I hope you still have a picture of OSI reference, starting from physical data link, network, transport, session, up to applications. So you are told before that when you are communicating in a network, in a fixed network specifically, there's a challenge which might come up whereby data collides. So we don't need a situation whereby data can collide during a communication. So that is why you came across something known as carrier sense multiple access collision detection and collision avoidance, CSMA/CD and CSMA/CA. So carrier sense multiple access with collision detection sense as soon as the media is free. These ones are mechanism put in place within the communication media so that there is no collision. So CSMA/CD listens for the media or listens whether there is a communication or the network is free so that it can be able to transfer data. So media access problems in wireless network happens in such a way that there is aspect about signal strength, which is also determined by the distance between the mobile stations. Sender would apply collision, that's carrier sense and collision detection, but the collisions happen at the receiver points, you see? Maybe the end station that is receiving, that is where collisions might occur. So sender may not hear the collision. So carrier detection does not work in this sense. So carrier sense might not work if a terminal is hidden. Sometimes vehicles are moving about. There is a barrier when the data was being sent. So once the vehicle comes up again, maybe, or gets connected to the internet or the network, then collision might happen, considering the data that has been relayed to that terminal. So this is an aspect about hidden and exposed terminals. For example, A sends to B, station A sends to B, and C cannot receive A. So C wants to send to B, but C senses a free media. Then carrier sense fails. Collision at B or A cannot receive the collision, C carrier detection fails. So A is in that sense hidden from C. We are just talking about a situation whereby we have mobile wireless stations, but the problem is that they are moving stations. Sometimes you are hidden because of barriers, but when you come up again, already data has been relayed and you never knew that there's some data being sent from a particular base station. You need to read about hidden terminals and exposed terminals. So multiple access with collision avoidance. Remember, we talked about collision detection. That is CD. And then now we are talking about collision avoidance. So multiple access with collision avoidance uses signal. This is the solution to that problem now. We use multiple access with collision avoidance as opposed to a static network, which we normally use carrier sense multiple access with collision detection. Because sometimes we have issues on hidden terminals or exposed terminals in that regard. So multiple access with collision avoidance works in such a way that it uses signaling packets for collision avoidance. So there are two aspects that needs to be understood clearly: request to send and clear to send. So when I want to send data from A to B, then I send an RTS request. So B, on the other hand, gives a CTS acceptance that, or the receiver grants the right to send as soon as it is ready to receive. Station B gives me a CTS once it has known that I have sent an RTS, request to send. So signaling packets, which is an aspect brought about by MACA, or what we say multiple access collision avoidance, avoids the problem of hidden terminals and also avoids the problem of exposed terminals. So for example, A and C want to send to B. Then A sends a request to send first, or what we say RTS, and C waits after receiving CTS, that is acceptance or a grant of acceptance from B. So you must be given these two aspects work: RTS and CTS, request to send and acceptance. What we say clear to send, or acceptance or grant of acceptance, before you are able to exchange data with the other station. So MACA avoids the problem of exposed terminals. So B wants to send, for example, to A and C. That is, B wants to send to A and C to another terminal. So now C does not have to wait, as it cannot receive CTS from A. So it is only guided by these two aspects, that is a request to send and clear to send. So I want you to understand this marker, which is something new, which you might not have covered before, but you have covered carrier sense multiple access with collision detection before. You have covered IEEE 802.3. That the technology allowing the communication to listen to the communication media before you are able to relay data, so that there is no collision. But now in MANET, we use multiple access with collision avoidance, considering signaling of packets, which is using RTS request to send and clear to send. So the station which wants to send sends RTS. The receiving station, if it is ready to receive, it sends a grant using clear to send or CTS. So that is it. That's about MAC reliability, which we can say wireless links are prone to errors, which you know. High packet loss is detrimental to transport layer performance. Remember, I said I want you to understand these manets again in aspect of how it is able to interfere with the OSI reference, so the different layers of protocol stack. That's why I'm saying high packet loss rate is detrimental to transport layer performance. Solution is use of acknowledgements. Remember, as I send an RTS to A, for example, from A to B, then an acknowledgement should come from B that it is ready maybe to receive, or it is not ready to receive packets. So those ones are RTS, acknowledgement, acceptance, like that. Remember this, you need to read this on uses of RTS and CTS exchange to avoid hidden terminal problem. Use of acknowledgement to achieve reliability, or acknowledging that I have received the packets. As soon as there is relayment of data, then you need to accept. The station should be able to accept. Now this aspect about collision avoidance again, I should be able to exchange with you this manual. So in the next class, I'll be interested to start on routing protocols. I'll be starting from routing protocols. So unless there is any concern. So I'll start the next class from routing protocols.